Hey, what's up? It's Jake from Nimbus DevOps, and we are going to play around with handling exceptions. So, to handle an exception in Python, you use the try statement. I use this a lot, and it is super, super handy. And you can use try statements in a lot of language. I use it in JavaScript a lot too. But when you enter the try clause, Python will watch out for one or more different types of exceptions according to however you instruct it to do it. And if they're raised, it will allow you to react. So a try statement is composed of a try clause, which opens the statement, followed by one more except clause that define what to do when an exception is caught. So the except clause can optionally be followed by an else clause, which is then executed when the try clause is exited without any exception raised, which is kind of nice if you need your code to continue. So after except and else clauses, you can have a finally clause, which is also optional, whose code is executed regardless of whatever happens to any other clause. And the finally clause is typically used to clean up resources. You're allowed to omit the except and else clauses and have only a try clause followed by finally. It's helpful if you want exceptions to be propagated and handled elsewhere, but there is some code cleanup that has to be executed regardless of whether an exception occurs. So, the order of clauses is important. It has to be try, except, else, finally. And remember that try must be followed by at least one except clause or a finally clause. And so now, enough of me talking, let's do something. Let's do a try. We're going to make a function called try syntax. And we're going to have a numerator and a denominator. Okay, so we want to try. What do we want to try? Print and then F in the try block, and then I'm going to give it the numerator divided by the denominator. Declare namespace. No, denominator. Denominator. Does it not see that? There we go. Denominator. I spelled it wrong. Denominator. Define try syntax numerator, comma, denominator. I'm checking my spelling, colon, and then I'm going to do a try block. Is this off? No, try. Okay, print this. Not sure why it's mad at me right now. And then we'll just say result is numerator divided by denominator, like that. Okay. Yeah, I don't know why my linter it's not defined. Denominator is not defined. Well, it will be. Okay, so yeah, why is it so mad at me? I don't know. Okay, well, we'll see. So now I'm gonna do an except clause, and I'm gonna say zero divisor error as zero divisor error ZDE, and we're just gonna print ZDE. So when I'm saying that, like zero divisor as ZDE, that's just letting me kind of like state that that's what I'm going to call it. All right. And then I'll do an else clause and say print the result is, and then comma, whatever the result is. And then we're going to return the result. And then I can put in a finally clause and say print exiting. Okay, so now if I come down here and I say print try syntax and do 12 and 4, and then I'll do another one and say print try syntax, and let's pass 11 and 0, divide by 0. Okay, so what do you think will happen here? I'm not quite sure what's going to happen here. So let's figure out why this is angry. I'm about to find out real quick. Python try syntax. Exiting, so it didn't do anything. It just went try, accept, else, and then went to finally. Exiting. Traceback. So remember, we need to read the traceback from the bottom. Name error. Name denominator is not defined. Did you mean demonator? Yeah, then you learn to spell denominator. There we go. So that's good. Look, even Python was able to go find what I was trying um, to type and provide a meaningful error enough for me to fix the problem. So in the try block, 12 divided by 4, the result is 3.0, exiting. 3.0 in the try block, 11 divided by 0, division by 0, exiting, and then none. So what exactly is this doing? Well, let's take a look. So we defined a simple try syntax function. We performed the division of two numbers. We are prepared to catch a zero division error exception, which will occur if we call the function with denominator equals 0. Initially, the code enters the try block. The denominator is not 0. The result is calculated, and after leaving the try block, the execution resumes in the else block because it did not raise an exception, right? We printed the result and return it. When you take a look at the output, you'll notice that just before returning result, which is the exit point of the function, Python executes the finally clause. When the denominator is 0, things change. Our attempt to calculate numerator divided by denominator raises a zero division error, and as a result, we enter the except block and print ZDE, which was the zero division error, and we saw that in my output. The else block is not executed because an exception was raised in the try block, and before implicitly returning none, we still execute the finally block. So take a look at the output and see whether it makes sense. So in the try block, 12 divided by 4, this is your try. The result is 0. This is your else, right? So there's no exception. It's going to do else. Else the result is, and this is the result. And then finally, okay? And then it says exiting. And then at the bottom, it says 3.0 because I told it to print it, right? So that's return. This is the return within the else, right? So we're returning this result. So at the end, it's going to return it. This is from here. Okay. Um, and then when we look down here in the try block, this is your try division. This is your except. This is your finally. And the none is the implicit return end of the function. Okay. Um, so when you execute a try block, you may want to catch more than one exception. For example, when calling like div mod function, you can get a zero divisor error if the second argument is a 0, or a type error if either argument is not even a number. If you want to handle both in the same way, you could structure it like this. Like I could say, I have some values, they're 1 and 2, and I want to try um, q r equals div mod and then star values. And then I could do an except and say 0 division error, comma, type error as E for error, and then just print type, which would be my type, right, of E, and then E itself, if that makes sense. Yeah. Except, oh, hey, how's it going? I only need one semicolon. Okay, there we go. So here's my values. This is what it's going to do. And what do you think? And this code is going to catch both the zero division error and the type error. If you could try changing the values and see exactly what I'm talking about. So let's launch this. It doesn't do anything, right? So it just says, here's some values, try this and accept this and print this out if there's an error. And there's not an error. They're both integers and they're both not, and the divisor's not 0. If I change this to 0, then what do you think is going to happen? Let's run this again. Class, 0 division error, integer division or modulo by 0. So that's where I was able to print out the type, which is here. This is the class 0 division error. And then the actual error, which was a 0 division error. And it tells you integer division by modulo or modulo by 0. So what if I made this a string? What if I made this like A? Then what happens? Name error. Name A is not defined. So there you go. Now, this is the name could be something, but if I did a direct string like this, because it probably saw A as an object, and it's not going to pick up my type error. But if I make it a string, a literal string like that, then it says class type error, unsupported operand type or types for div mod int and string, because I have an int and a string. So that is a little bit about the raise exception. If you need to handle different exceptions types differently, you can just add more except clauses. So if I had this try qr div mod values, and what I could do is instead of doing this, I could say except zero division error. If you get that, right, I want to print you tried to divide by 0. And I could actually add a second except here and do a type error as E, and I can just print E. So now I've handled them two different ways. So you can do this as many ways as you want, but just keep in mind that an exception is handled in the first block that matches the exception class or any of its base classes. Therefore, when you stack multiple except clauses like we just done, you have to make sure you put specific exceptions at the top and generic ones at the bottom. In object-oriented programming terms, that would be like the children on top, the grandparents at the bottom. So remember that only one except handler is executed when an exception is raised. So you have to test this a lot with a lot of different scenarios to make sure that your exceptions are returning they're raising the exception you're expecting given that scenario. You can also raise exceptions from within an except clause. So you might want to replace a built-in exception or one from like a third-party library with your own. It's pretty common when writing libraries. It helps you shield users from implementation details of the library. And we can take a look at what that looks like. Let me go into an interactive shell. And let's say class not found error, and then pass exception. And then we're just going to tell it to pass. And then I'm going to say vowels equals A is going to be 1. E is going to be 2. Now let me get 5. We'll make I is 9. This is a like letter in the alphabet. O would be letter 15. And U would be letter 21. Okay, there were my vowels. So now I want to try. What do I want to try? Position equals vowels, and I want to find Y because it's sometimes Y, right? So let's find Y. Oops, Y. And vowels is plural, right? Yeah, okay, I did pluralize vowels. Okay, and then we want to accept key error, because we're going to have a key error as E. And if we get it, we want to raise not found error and then star e.args, wherever the args are. And there we go. And we get a traceback. Key error Y. During handling of the above exception, another exception occurred. Not found. Not found error Y. So by default, Python assumes that an exception happened with an except clause because an unexpected error happened, right? And it prints out the traceback, but for both exceptions. We can tell the interpreter we're deliberately raising the new exception by using a raise from statement. So the error message is changed and you still get both tracebacks, which is actually pretty handy for debugging. And if you really wanted to completely suppress the original exception, you could use from none instead of from E. So like if I did this, and I didn't do it in code, but like if I had just replaced this with from none instead of from E, then it would have been this initial one would have been completely suppressed, and you would have just gotten this second traceback. So, programming with exceptions is kind of tricky, as you've probably noticed. You could inadvertently hide bugs by trapping exceptions that would have alerted you to their presence. So, it's probably best to play it safe and keep a couple things in mind. So, keep the try clause as short as possible. It should contain only the code that may cause an exception that you want to handle, and make the accept clause as specific as you can. It may be attempting to just write accept exception, but if you will almost certainly end up catching exceptions that you did not intend to, you keep that in mind. And then use tests to ensure your code handles both expected and unexpected errors correctly. And I'll get into more on writing tests and stuff later. But when you're testing your code, you should be passing correct and incorrect values to determine whether or not your raise exceptions are functioning as intended. So that is it. I know it was a little bit of a longer one, but now you know a little bit more about handling exceptions. If you have any questions, give me a shout. And if not, then I'll see you in the next one.